All right, let's just jump right in. There is a firestorm absolutely raging in the world of theoretical physics right now. But what's interesting is that it wasn't sparked by some new discovery. Nope, it was ignited by a really scathing critique from within. So today, we're going to break down the accusation, the evidence, and the systemic problems that one physicist is claiming have stalled fundamental science for pretty much half a century.
It all kicked off with this incredibly blunt, you might even say brutal statement from physicist Dr. Sabine Hossenfelder. She did not mince words, and you can tell the language was chosen very deliberately, so her position on a huge chunk of current research would be absolutely impossible to misunderstand.
And wow, the fallout was swift. A formal complaint was filed against her, and not long after, Hossenfelder lost the key university affiliation. So right away, this stopped being just some academic debate. It suddenly had very real, very serious professional stakes, and that really sets the stage for the deeper conflict that we're about to get into. So what is this really all about? I mean, if you look past the provocative language, Dr. Hossenfelder is making an extremely serious charge. She's basically arguing that a huge part of foundational physics has completely stopped following the scientific method and has become, in her own words, pseudoscience. Now, it's so important that we understand what she means by pseudoscience here. This is not just some random insult she's throwing around. She's defining it as a very specific methodological failure. A way of creating theories that simply does not learn from its own mistakes, and because of that, has failed to produce results for decades. This is a critique of the process, not the people doing the work.
So what kind of research is she talking about exactly? She has a name for it: mathematical fiction. And the targets are probably going to be familiar to you. They're all the big headline grabbers: multiverses, extra dimensions, this whole zoo of invented particles and forces. She's arguing that these are just beautiful, elegant mathematical stories with zero evidence connecting them to actual reality.
And Hossenfelder's argument isn't just some philosophical disagreement. She claims it's backed up by a very clear historical record, a 50-year track record of total failure. Her entire argument really centers on this idea of a great divide in physics. Before the 1970s, you had physicists solving real observed problems, making predictions like the Higgs boson that were later proven right. But then, she says, around the 70s, something changed. The field shifted and started inventing mathematical ideas for things that had never actually been seen. And that new method? Well, it's produced decades of failed predictions ever since. This slide really gets to the heart of her argument. The proper scientific method is supposed to learn from its mistakes, right? To refine how we even choose our hypothesis. But this failing method, as she calls it, just ignores the failures and keeps guessing with math that just feels nice or beautiful. It's the difference between developing theories to explain real data versus just inventing math to explain nothing at all.
And you know what? This isn't a problem that's totally unique to physics. It's a pattern we've actually seen before. Just think about the replication crisis that completely rocked the field of psychology. You had a widespread failure to maintain high-quality standards, things like p-value hacking, and it led to this flood of studies that just couldn't be reproduced. It just goes to show what can happen when an entire field of science fails to correct itself.
Okay, so Hossenfelder makes a very, very controversial comparison here to really drive this point home. She quotes an ex-naturopath who described her old field as this self-reinforcing belief system that, from the inside, felt exactly like real science. The argument is that for the people within a system of groupthink, it can be almost impossible to see the flaws that look so obvious to an outsider.
And that brings us to our next major point. This isn't just about a bad method. It's about the social structures, the institutional systems that have grown up around it to protect and perpetuate that method. It's what she and others are calling a system of groupthink.
And, believe me, she is not alone in this critique. Another cosmologist, Will Kinney, describes the constant flood of papers in his field as, quote, mostly useless. He calls them an exercise in empty mathematical world-building, where nobody, not even the authors, really expects the models to be correct. Physicist Jasper Grimstrop echoes this exact same idea in his book, The Ant-Mill. He talks about a massive social force that's pushing all the researchers toward these mainstream ideas, and it creates this kind of tribalism that just completely stifles any genuinely new thinking. And all of this leads to a self-perpetuating cycle that they call the ant-mill. And here's how it works. Step 1, you invent a mathematical model. Step 2, you produce a paper about it. It doesn't matter if it's useful or not. Step 3, it gets published because the quality standards are so low. Step 4, that publication helps you get funding and build your reputation. And step 5, you just repeat the whole thing over and over again.
So you have to be asking yourself, right? If the problem is so well known behind closed doors, why don't more physicists speak out? Well, the answer is pretty simple, and it's very human. Professional risk. Their funding, their careers, their reputations. It all depends on playing by the rules of the system. To break ranks comes at an absolutely enormous personal and professional cost.
So, after diagnosing this problem in such stark terms, does she offer a solution? Well, yes, she does, and she argues it's a surprisingly straightforward one. Her proposed fix is a simple two-question test for academic journals. First, does the new theory only make assumptions that are actually necessary to explain existing data? And second, does it solve a real problem of mathematical consistency? If the answer to both of those questions is no, she argues, it's just mathematical fiction and it should not be published. Simple as that.
Which, of course, brings us to the obvious question. If the solution is really that simple, just a two-point checklist, why hasn't it happened already? Why does the ant mill just keep on turning?
Well, the answer, as it so often does, really comes down to incentives. It's about the money. The journals themselves benefit from a huge volume of papers. See, more papers and more citations help them sell those super expensive subscriptions to university libraries. In short, pretty much everyone inside the cycle has a very good reason to keep it going.
And this leaves us with a final and honestly a pretty unsettling thought. This whole controversy, it isn't just about dark matter or extra dimensions. It's about the very foundation of the scientific method itself. So the really crucial question to think about is this. What happens to our search for knowledge when an entire field of science, for whatever reason, just stops learning from its own mistakes?